Okay, Dr. Osborne on the train. Staying on the train car that's moving on a straight level track at a speed of, sorry, let me get the computer arranged. There we go. Speed of 10 meters per second. Okay, here's what we need to know about this problem. There's the track or the train, there's Osborne, and this thing is moving at 10 meters per second. So, velocity of the train with respect to the ground is, we're just going to say 10 I hat. Okay, so x, y, no problem. Now, Osborne throws it at an angle of 60 degrees above the horizontal, and to you it appears as though the ball rises straight upwards vertically. You're in the ground's reference frame, right? So velocity of the ball with respect to the ground, and I'm just going to call this the initial velocity of the ball. Okay, we're going to worry about the time dependent stuff later. So this is all just initial blah blah initial. Pretend it says initial. Okay, so is something in the j hat direction. Okay, and the last thing we need to figure out is the velocity of the ball with respect to the train. And so to make these into an addition, and that is at something at a 60-degree angle. We'll get there in a second. Okay, but to make these into a correct addition statement, the only option is velocity of the ball with respect to the ground equals velocity of the ball with respect to the train plus velocity of the train with respect to the ground. Okay, and so let's see, this is going to be all in the j hat direction, and so v, hold on, let's see, so our ball velocity with respect to the ground is entirely in the positive y direction. Okay, and our velocity of the ball with respect to the train we're going to get to in a second. Okay, and then the train with respect to the ground is entirely in the I hat direction. So what this means is that VBT, the x component of VBT, has to be negative. The I hat part of this has to be negative in order to cancel this out. In fact, it has to be negative 10, because otherwise you got this problem. Okay, so what this has to be, in fact, you can go ahead and solve for VBT. It has to be, right, it has to be V, well, hold on. Okay, it has to be negative 10 I hat plus VBG J hat, the speed of the ball with respect to the ground up. And then the horizontal component of it has to be negative 10 I hat. What this means, and this is the thing that I think some people have trouble seeing, or don't realize at first. Once you realize it, it's pretty obvious. But the train is going to the right, which means Dr. Osborne, if the ball is going to, say you're standing there, standing still, while the train goes this way to the right, then in order for the ball to appear to go straight up for you, Dr. Osborne has to be throwing it behind him, or he has to be throwing it towards the back of the train. So this is how Dr. Osborne is throwing it. He's throwing it at a 60-degree angle above horizontal, but backwards, okay, toward the back of the train. So once you see that, it's pretty obvious, right? So anyway, for the angle of this to be, this is V ball with respect to train. So for the angle of that to be 60 degrees up, or really it's 120 degrees, right? So it has to be basically VBG, if you do the trig, the velocity of the ball with respect to the ground, or the speed of the ball initially with respect to the ground, it has to be, let's see, oh, come on, it's a freaking 30, 60, 90 triangle. It has to be equal to 10 square root of 3 meters per second. Okay, so to you it appears as though the ball is rising initially at a speed of 10 root 3 meters per second. Why have I left this as a radical? Because I'm going to show you in a second. Okay, so now we just need to find out how far does the ball rise above its release point. So now we're just in your reference frame, you're watching as, and your body is disconnected from your legs, and of course your head is disconnected from your body. Okay, but that's your problem, not mine. So it initially has this, the ball has this initial speed, or initial velocity in the y direction of 10 root 3, and then it goes up and comes to, we'll call this v final in the y direction is 0. Okay, so it goes up and then momentarily stops. And so the height it rises is delta y, no problem. And then we just use 1/2 v final y squared minus v initial y squared equals acceleration of y, times change in y. Okay, so again, as I've said before, really awesome people, acceleration y is negative g, and really awesome people use 10 for g. Okay, because it makes things easier. Okay, so vfy squared is 0. So let me just take this whole thing forward. Okay, 1/2 vfy is 0, 0 squared, minus, and then v naught y is 10 root 3. Now plugging it in there and squaring it. So see, this is where the whole, keeping the radical comes in handy, because then 10 root 3 squared is just 100 times 3, so 300. And that's going to equal acceleration y, which is negative 10, and then delta y. And so what you'll get is, then you'll get delta y equals 15 meters. So the ball rises 15 meters above its release point. If you use 9.8 for g, then, a tiny bit higher. Whatever. That's problem, whatever it was, 6.